Hello everyone, welcome to the very first episode Cloud with CJ, where we learn, build and grow together in the world of cloud computing. Whether you're just starting off your cloud journey or already hands-on with AWS, this channel is all about turning cloud theory into practical real-world project. And to kick off, we are diving straight into one of the most important and powerful services in AWS, the Elastic Load Balancer. Specifically the Application Load Balancer, ELB. Alright, before we even jump into the console, let's first understand the basics of Elastic Load Balancer or ELB. Let's start with a real story. Imagine you have got your own e-commerce website. Let's call it CJ Store. You start selling tech gadgets, accessories, and cool stuffs online. At first, things are simple. You've got one EC2 instance, which could be a web server running your site, and it's handling everything just fine. Then December rolls out, the holiday season. You decide to launch a big end of year discount campaign, 40% off everything, banners all over social media, email blasts, or maybe even a TikTok advertisement. Suddenly, traffic starts spiking. Hundreds of users start flooding your site at once, adding items to their cart, checking out, refreshing pages, and other actions. At first, your server hangs on, but then the CPU maximizes out. Memory gets tight. The pages start loading slower, and slower. Few minutes later, boom, your instance crashes. Now your site is down, customers can't reach you, and you're losing sale in the most profitable month of the year. That's the moment every cloud engineer learns one hard truth. Scaling manually doesn't work. You need something that can handle traffic automatically, spreading it evenly across multiple web servers, which could be EC2 instances, so no single one get overwhelmed. That's exactly where Elastic Load Balancer or ELB comes in. Think of it as a, let's call it, traffic manager sitting in front of your web servers. When users visit your site, the load balancer doesn't send everyone to the same instance or same web server. Instead, it checks which servers are healthy and spreads the requests intelligently among them. If one instance goes down, then the ELB will automatically reroute the traffic to another EC2 instance or another web server, keeping your site online without lifting a finger. AWS gives you different types of load balancer depending on your application needs. We have application load balancer, network load balancer, and gateway load balancer. So in application load balancer, it is perfect for web traffic like our e-commerce site because it works at the application layer and can reroute requests based on things like URL or host name. Then for network load balancer, it is for extreme performance and low latency application like gaming or even financial systems. Then about the gateway load balancer, it is actually used when you are dealing with virtual firewalls or intrusion detection systems. For our store example, the application load balancer is exactly what we need. It understands the hypertext transfer protocol, HTTP or HTTPS traffic, so it can look at requests and see and see that it is exactly 4, for example /checkout/images, and reroute it to the right set of servers. It is smart, scalable, and secure, the perfect foundation for any modern web application. Alright, we are now in the AWS console. So this is the dashboard that enables us to spin various resources in AWS. The search box type EC2 basically stands for Elastic Compute Cloud. So after coming to the EC2, as you can see on the left sidebar, these are the features of the EC2. So for us, we shall start by creating security group. Create security group. So what are security group? A security groups act as a virtual firewall for your instance to control inbound and outbound traffic. I'll call it store security group. Store SG. In the description I can just type allow. I'll select the default VPC. For the inbound rule, I will add HTTP and HTTPS. For the source, I'll put from anywhere. So after that, I'll just create the security group. Let us also create another security group for the load balancer. ALB SG, say allow. Select the same VPC, inbound rule, the same HTTPS, which stands for Hypertext Transfer Protocol. Source anywhere. Create the security group. After that, I'll navigate to the target group. So after that, what I'll do, we're going now to launch some instances. So I'll click instance, then I can call it store web server. Also I'll create an AMI. An AMI contains an OS application server application for instance. AMI basically is it's just like a template that contains certain configuration. I'll select the AMI, Amazon Linux and its version, and instance type T2.micro, which basically defines the number of CPU, the RAM, the charges. In the key pair section, I'll proceed without key pair. The network section, security group, then select existing, then select the one that we have created, which is store SG. We get downwards. Here is where we put some commands that will run during the first boot of the EC2 instance. So I'll copy this command. So what this command does, it updates this is a script that updates an instance, updates packages first. After that it installs Apache and then enables it. Then it creates some HTML file which contains title as let's learn AWS, and also some paragraph let's learn AWS displaying the host name. Alright, so what I'll do, I'll launch 2 instances. I just click launch instance. You can just come here to confirm, click state running. As you can see, they are still in the initialization. So as they initialize, we can just create what is called a target group. Target group basically allows load balancer to reach the resources. After creating target group, I'll just register these 2 instances as the target. So I'll go to target group, create target group. Target group can also be a lambda function, IP address, or even another application load balancer. So I'll just select instances since we are dealing with instance. Then the target group name I can call target group webtg. Hit next. After that, as you can see, I'm able to see the available instances in which they are in this zone US East 1D. Just select both of them, include as pending. After that, click next, create target group. Alright, I can see we have already registered 2 targets. So after that, we'll go back to the EC2 to see if they are already running. So let us check if our command executed successfully. So to do so, I'll go to networking section, copy the public IP, open a new tab, then type http:// the IP, hit enter. So you can see This seems to be launching. Let us wait and see. Let us try this one, network. Then copy the public IP, http :// the IP. So this is the private IP address, which is 172.31.23.84. If we come here and check the private IP address, IPv4, you can see it is the same. Alright, so let us again try this first one, the public IP. Type http :// IP. It's working. You can confirm by coming to tracking, then the private IP is the same. Now we are going to launch the load balancer that will distribute traffic these target groups, which are these instances, the EC2 section, into the load balancing. Then select load balancer. I'll create a load balancer, application load balancer. Hit create. Load balancer name, I can call it store ELB. It will be an internet facing, meaning it will get a public IP address, VPC, the default one. Remember, we deployed our target groups, the instances in US East 1D. It means that we must select this so that the load balancer can reach the target group. So for our case, I'll just select all of them for high availability. Under the security group section, for the load balancer, as ALBSG will forward to the target group, which is web target group. Roll downwards, it creates load balancer. For the load balancer, it will take some time, so let us wait for it. As it provision, we can navigate target group, then open it and just see. As you can see, the health status is unused. As you can see, it is started to initialize. Alright, the status now has changed to active. AWS has given us the DNS, so we can just copy the DNS, open a new tab, ://. Alright, as you can see, it is working. To ensure that Elastic Load Balancer work, we need to refresh to see if it distributes the traffic between the instances. What does that mean? It means that the private IP will be changing. So let us try. As you can see, see now the load balancer is distributing traffic across the targets. Alright, for our case, we can also access the instances directly, which is not a good practice. The instances should reject any traffic except the one coming from load balancer. So to do that, we'll be going to the security group again. After that, I'll click that security group, the instance, then edit inbound rule. So I want to show you something here. If I try to remove this, then try to put the source security group of the load balancer, you can see that it is saying you may not specify a reference. So this means that this rule is already in place, so I cannot edit this rule. To replace it, just need to delete the rule, then create a new one. Type is HTTP, then now the traffic, I can put it to originate from that security group of the ELB. Also for the HTTPS for security group of ELB. Okay, that way. Then save. Awesome. So to test, I can incognito tab. Yes, it is now working as we set up a secure access. And that's how we set up application load balancer. But wait, and that's how we set up application load balancer. But wait, what if you want to scale up or scale